Hello everyone, happy World Water Day 2020. Thank you, Stefan Krause, for inviting me to give this presentation on conserving and restoring wetlands in the climate change era. And I'm going to explain who the allies are for this uphill battle, mainly citizen scientists with whom we worked over the years with various collaborators in other countries as well. First, environmental change context, then citizen science, then freshwater watch program, and then the bigger picture on science, conservation, and restoration. Water and wetlands are subject to various pressures, anthropogenic impacts, but these do not include what's coming next. The energy trapped by man-made global warming pollution is now equivalent to exploding 200,000 Hiroshima atomic bombs per day, 365 days per year. James Hansen reminds us of that. Probably not hearing the audio, which is quite scary, but this is the energy levels we are talking about. And wetlands are very much at the center of the carbon cycle as well as the water cycle. Carbon sinks, but they can also be carbon sources, which is problematic. Wetlands help mitigate and adapt to climate change as well, so we need to preserve them for their carbon sequestration function, but also for their unique and wonderful biodiversity. And wetland managers need to do more, politicians need to do more to sustainably manage and conserve and restore wetlands. And this is from the Intercol Wetlands Conference, Changshu Declaration the year before, in 2016. A lot of activities, therefore, have been conducted by scientists, also in terms of lobbying for systematic change. But we need citizen science. We need citizen scientists who, between the engagement and education function of citizen science and the actual research that professionals conduct, can do good. Citizen science is people's power to do good. More technically, it's scientific work undertaken by members of the public in collaboration with us scientists. And it's to address knowledge and funding deficits and get more data and engage, raise awareness amongst the general public, retirees and youth. And also, we can harness technology to do this. A lot more publications have been published in the last 10 years or so on citizen science work, which is great. We have super users who do a lot, and we have inquisitive users who do less, can engage less, but there are many. And so we can then rely on a lot of data that otherwise would have not been in our hands to understand processes and implications. How do we deliver good citizen science? Well, the European Citizen Science Association came up with some advice, and it's a lot to do about mutual benefits for scientists and citizen scientists, public available data, acknowledgement of the work of volunteers, citizen scientists, evaluation of projects so that we can improve, and considerations on intellectual property, confidentiality, and environmental impacts on the ground. So our Director of Science Policy and Innovation came up with this great citizen science pathway diagram, which includes the collaboration between different actors to produce evidence, to increase understanding, and then help management, policy, and political advocacy to create institutional, collective, and individual practice change. Many groups are using some form of monitoring involving volunteers and citizen scientists, from invasive species to invertebrates to freshwater habitats in general, and nutrient quality. I'm going to talk about Freshwater Watch as a flagship program of Earthwatch Europe, environmental charity with science at its heart. We drive the change needed by connecting people with the natural world, monitoring the health of our natural resources, and informing the actions that will have the greatest positive impact. So the research questions of Freshwater Watch are: what are the causes of the loss of freshwater quality? Why are freshwater ecosystems degrading? And the big picture purpose is to inform better management and protection of the world's freshwater. This is, by the way, near the office in Oxford, where our colleagues were measuring nitrates and phosphates through the Freshwater Watch simple colorimetric method. So far, 24,000 data sets have been collected in all continents pretty much, with a majority in Europe, but we have a lot of data coming from Africa and South America and North America and Asia, as you can see. We have these inquisitive users, many youth and their families, and they come up with improved understanding of their environment and changed behavior. For example, in the Thames Water Blitz that runs twice a year. And then we get specific local data from the Chilterns area near Oxford again, where we can see low, moderate, or high pollution based on these nitrates and phosphates colorimetric measurements. So water is central to sustainable development, and wetlands are as a result. It's not only the clean water and sanitation sustainable development goal, but other goals that relate to wetlands, and wetlands relate to these goals, like life below water, number 14, or other ones including good health and well-being. And the Freshwater Watch worked with volunteers and NGOs and authorities in Indonesia at the river catchment level near Jakarta, with results for resources management plan, and with farmers reducing their fertilizer dosages in fields. And then we also have work in Zambia, for example, with the Kafue River Research Center, and dealing with hydropower generation, water quantity and quality measurements and changes, again, from upstream to downstream, with various important international organizations, including UNESCO and local partners and NGOs and WWF. So now let's move on to how do we fix the wetlands that have been degraded and destroyed over the past several decades. So restoration means recovering the habitats, naturally managing the floods, improving the water quality, defragmenting the habitats, and improving the quality of the ecosystems in the way that people enjoy them for recreational purposes, and reducing pollution and cutting these invasive species. But the Earth keeps losing wetlands. How can we make wetland restoration succeed better and faster? So based on work carried out at Florida International University in the past 4 years, before last actually, so we came up with some challenges. So restoration projects focus on few benefits. They may have not well identified or static targets. Ecosystem baselines change. Results may be unrealistic, and other reasons. So I worked on the Everglades, and the Everglades is a case in point of how restoration is fundamental to fight eutrophication and sea level rise, with millions of jobs and billions of dollars in economy, from fisheries to agriculture and recreation, at stake if there isn't enough fresh water flowing south into the Florida Bay and Gulf of Mexico from this other area. Freshwater, estuarine, marine habitats, all interested in this project and prospect. Possible solution to the conflicts of interest and targets between, for example, farmers, developers, conservationists, and water managers, and conflicts also between water quality and water quantity targets and goals. is that we look at the whole picture of the river basin, from the headwaters to the estuary in the delta, or downstream in general, in a typical wetland. And we can allow some restoration brokering. So we have some independent authorities appointed who can mediate between conflicting interests, especially to help those stakeholders that are disadvantaged and have fewer resources. And this is published in the Solutions Journal 2018. Together with these other recommendations that we came up with, colleagues in the US and Australia as well. So we need standardized internationally agreed protocols, and we need to use traditional knowledge, and watershed sustainability plans need to be taken and applied. Independent wetland restoration brokers, as said, can help solve these conflicts of interests and power struggles. And existing cultural and spiritual values that need to be taken into account, not just the ecosystem services that have a monetary value. So there's quite a lot of homework for us all to go home and do. And we also, I think, need to consider how interdisciplinarity and multidisciplinarity is all well, but we need to work transdisciplinarily to achieve a higher level of synthesis between ecological, economic, and socio-cultural aspects of sustainability, in a way that the environment is always the overall goal, because the economy is contained in the environment, and society is contained in the environment as well. So the take-home messages for me today are that our climate is not the only thing that is changing. Citizen science increases power for statistical analysis by giving us a lot of data, increasing awareness and engagement among the general public, and achieving positive environmental change from the bottom up, if you want. Wetlands, from mountains, streams to urban ponds, swamps, estuaries, and coral reefs, are affected by climate change. But wetlands can mitigate climate change by sequestering carbon and attenuating sea level rise impacts on coasts. Think about mangroves, for example. So with this, I thank you very much. And if you have any questions, you can email me at this address, or you can tweet Earthwatch Europe and myself, as well as my colleague Isabel Bishop, who provided a good number of the slides that I presented to you today. So thank you very much again for your attention, and until next time.